Hello everyone, welcome back. In this video, I want to talk about simplifying our square root expressions that result in these complex numbers. In particular, I want to talk about taking the square root of a negative number. And so here I have some notes that are going to walk us through that process. And this process is really like an application or alternate form of that product property for radicals that we've seen earlier. And so we're writing this up for negative numbers. So if x is positive or greater than 0, then negative x will be a negative number. That's just making sure the thing underneath our square root is actually negative. So if we do have a negative underneath our square root, then we really do factor that like we're using that product property for radicals. We'll break it apart as the square root of x multiplied by the square root of -1. And then that square root of -1, we always turn into and write as that imaginary unit I. So that gives us the square root of x times I, or I times the square root of x. The order there doesn't matter because it's just the order of multiplication, but sometimes you'll see one order over another just for clarity. All right, so let's go ahead and apply this idea to a couple examples. And let's start with a simple one like the square root of -25. And so we don't always need to write this work out every time we simplify one of these radicals. This is probably the thought process we should be going through in our heads. And so we start with the square root of -25. We recognize that we're taking the square root of a negative number, and that should give us a complex number. And so we're going to break it apart as the square root of the real factor, which in this case is 25, multiplied by the square root of -1. And now we're going to try to simplify or evaluate that radical as much as we can. And 25 is a perfect square, so we can take the square root of 25 to get 5. And then we're going to multiply that by the square root of -1. But we're going to write that using our complex number notation. We're going to turn the square root of -1 into the factor of the imaginary unit I. So the simplified way to write the square root of -25 for us is going to look like 5 times I. All right, so here we have another example of a square root of a negative number that we want to figure out how to simplify. And so we're going to start with the same steps that we always do and that we did in our previous example. And that's breaking it apart as the square root of the non-negative number multiplied by the square root of -1. And so in this case, we can break it apart as the square root of 8 times the square root of -1. And so now our square root of -1 will turn into a factor of I. However, our square root of 8 quantity, we could just write it as the square root of 8 times I, but that is not fully simplified because we can simplify the square root of 8 a little bit further by pulling out its perfect square factors. And so what I mean by that is we could write that as like the square root of 4 times the square root of 2 to break up our square root of 8. We still have to bring down and can't forget about that factor of I. But now we can evaluate this and write this as like 2 times the square root of 2 times I. So the simplified form of the square root of -8 is going to look something like 2 times the square root of 2 times I. Let's look at another example of taking the square root of a negative number. This time we're going to look at taking the square root of -10 and trying to simplify that. And this one's going to be pretty quick because there's not a whole lot that we can do with this problem. So we're going to start like we always do by breaking it up as the square root of a positive number times the square root of -1. And well, we have to pretty much stop after this step because we can't take the square root of 10. It's not a perfect square. And there are also no perfect square factors inside of there that we could pull out, right? We can't write 10 as like 4 times 2. We can really only break it down as 2 times 5. And, neither of those are perfect squares. We can write that square root of -1 as an I though, and we should. And so here's the case where we could leave our final answer as the square root of 10 times I. In this case, it's very clear that our I is definitely not underneath that radical, and we are not taking the square root of I. But because we only have a square root of 10 multiplied by it, it's not too uncommon, and you may also see it written as I times the square root of 10. But if there was another constant factor in there, which we sometimes see, then we probably would just leave I at the end like we did initially.